Hello everyone, and welcome to the Tree Methods Consulting Project. You've been contracted by the Purina Dog Food Company and flown out to their headquarters in St. Louis, Missouri. So you've been hired by this dog food company to help them try to predict why some batches of their dog food are spoiling much quicker than intended. Unfortunately, this dog food company hasn't upgraded to the latest machinery, meaning that the amounts of the 5 preservative chemicals that they are using can vary a lot. But you want to answer the question, which of these chemicals is having the strongest effect? So the dog food company first mixes up a batch of preservative, and then that preservative contains 4 different preservative chemicals labeled A, B, C, and D, and then it's completed with some sort of filler chemical. Now the food scientists working at this dog food company believe that one of the actual preservatives that is labeled, either A, B, C, or D, is causing the problem of the dog food spoiling early, but they need your help to figure out which one of these chemicals it is. So you're going to be using machine learning with random forest to find out which parameter had the most predictive power, thus finding out which chemical causes the early spoiling. So you're going to create a model that tries to predict which dog food samples will spoil, and then find out if you can decide which of the features, in this case the preservative chemicals, is the problem. So their data that they presented you with looks like this. They have the 4 preservative chemicals that are not the filler, so preservative A, B, C, and D, and the actual value is the percentage of the preservative A in that particular mix. Then you have a label column of spoiled, indicating whether or not that dog food batch was spoiled early. So think really carefully about what this problem is really asking you to solve. In fact, you don't actually need to perform such a complicated machine learning task like random forest, but I want to reflect a reality in consulting projects where sometimes a company asks you to solve a project where you didn't need full-blown machine learning to do it, but you could solve it anyways using that. So while we will use machine learning to solve this, it actually won't be your typical train test split workflow. If this confuses you, skip ahead to the solution code along, but try your best to figure out which actual chemical is causing the early spoilage. Alright, best of luck on the project, and I will see you at the next lecture where we'll go through an example solution to solving this actual task.